So today we are going to be talking about arranging people in a circle, which these wonderful volunteers from among your classmates are not yet in a circle, but we're going to start with something that we already know. How do I figure out how many different ways they could have arranged themselves in this line? What's our formula for putting 4 people in a line? Come on, this part's review. Grace. Or 4 factorial, so we already know how to do that. If we have people and we want to put them all in a line, it's however many we have factorial. Okay, now we're going to get to the hard part. I need you guys to stand up for a minute. And I'm going to move these around, sort of a circle, but trying to have these chairs far enough apart that you aren't tripping over each other or kicking each other as we move around and form different permutations. So each of you stand in front of a chair. Don't actually sit down because we're going to be moving around. I'll move this one up just a little bit. So would everybody agree this is one permutation, one way we could arrange them in a circle? Okay, now I want you to each move one chair that way. Look to your left and your right. Do you still have the same people on the left and the right as you had before? So this is still the same circular permutation. When we're talking about circles, we're talking about everybody or everything, if it's objects, having the same on the left or the right. It's the same permutation no matter exactly which position they're in. Okay, rotate once more. And look left and right again. Is this the same or a different permutation? It's still the same. So far we've had 3 of the same. Is that all we could have? Oh, move. Okay, move again. Is this just so you're different chairs now, but is this the same left and right? Okay, so now we've had 4. If you move again, will you be back where you started? Okay, so we have, well, let's not move yet. So there are 4 different ways they could rotate, and it's still the same circular permutation. So it doesn't really matter which chair they're in. It's the position of who's on their left and who's on their right. So since we had 4 people, we had 4 ways they could rotate. That one repeated 4 times. Let's see if we can manage to make a different permutation this time. So Kinsley and Gina, you 2 switch places. Now everybody look to your left. Do you have anybody different on your left than you had before? So now this is a different permutation. So now the rest of you guys have to do the work. How many different times could that one repeat? 4, because we have 4 people. Could we do a different one? Okay, so Kay and Gina, you 2 switch. Look to your left and to your right. Is it the same as who you had the first time around? Or that second one we just had? So this is a 3rd permutation. All right, I'm going to let you guys go back to your seats now so you can start taking down some notes. It was hard work just to move around. Well, sometimes we got to move around, especially after lunch so we don't move into siesta mode or anything like that. I better slide these enough out of the way that I don't trip over the chairs. All right, if I had put letters on those chairs, A, B, C, D, so that we could tell them apart, it would have been like in a line, and we would have had 4 factorial ways of arranging them if it made a difference which chair they were in. But that's not what a circular permutation is. So each one of those repeated how many times? So if I have each one being duplicated 4 times to get the ones that I can tell apart, I'd have to divide by 4 because I could take groups of 4 that are always the same. Does that much make sense to everybody? That's kind of a messier formula than I really want to have to work with, so I'm going to simplify it a little bit. I could 4 times 3 times 2 times 1 and divide by 4, and my 4s would cancel out. So if I had had 12 students in a circle, I would have had 12, 11, 10, and so on, divided by 12 repeats. The 12s would cancel out. So the first one is always going to cancel out. So if we want to know how many we have in a how many circular permutations we have, we just take 1 less than the number of people or things and do that factorial. So if I had 100 students in a circle, it would be 99 factorial. Does that much make sense? So let's add to our formula list. First one is actually review. You already know that if we are arranging in a line, we have n factorial possible ways. And now we are saying for circular permutations, we just take one less and take that factorial. The last formula up here, we will talk about some other examples, and then we will come back to this slide to fill in what I'm talking about with that last formula. So if you haven't quite copied this down yet, that's fine. I'm going to have this slide back up here, and you can finish copying it down when we get to this last formula for today. But let's go ahead and practice with the lines and the circles with an example. So if we have 6 items and we want to know how many ways we could arrange those in a line or in a circle, since this problem is asking 2 different things, I need to label which answer is which. So I need to find how many ways to arrange in a line and how many ways to arrange in a circle. So Kyle, help me out here. What's my formula for if I want to arrange them in a line? So 6 factorial, 6, 5, 4, 3, 2, 1, and who's got your calculator or feels like doing that as mental math? I need an answer from you guys. What does that equal? How many ways can we actually arrange them in a line? If you'd rather do 6, 5, 4, 3, 2, 1, that's fine. Okay. Anybody else coming up with 240? I think maybe you missed one of the factors in there. Natalie, what you got? 180 for 6 factorial? 720? How many are getting 720? Give me thumbs up, thumbs down. Okay. Most of you are getting 720, so we'll go with that. So 720, and it asks 4 ways. So that was just review. So now, Aiden, what is my formula if I'm going to put those 6 in a circle? 5 factorial. So everybody figure out what 5 factorial is. Everybody do it on your calculator, or do it mental math, or do 720 divided by 6. Everybody got your answer? Okay, on the count of 3, I want you to shout it out. 1, 2, 3. So 120 ways there. So is everybody comfortable with lines and circles? It's just factorials plugging in there. Okay, now let's talk about that third formula that we'll go back to in a minute. Distinguishable permutations. We're going to talk about those when we're talking about arranging a group of things or a group of people, and some of them look just exactly alike. So in this case, all of my red marbles look just exactly alike. I can't tell them apart unless I take a marker and start putting numbers on them or something. If it's, some of the problems are going to be talking about identical twins and triplets, and yes, I know their parents can probably tell them apart, but I usually can't. So when you get those kinds of problems, we're going to assume we can't tell them apart. So for this one, if I've got my red and my purple markers, or my red and my blue and my green marbles, got distracted there with my marker kind of messing up on me. And let's see, I'm just kind of going to do some sort of a random way of arranging these. Would you agree that's one way I could arrange those marbles in a line? Okay, now, I'm not going to be able to tell it apart if I switch those 2 red marbles. That looks just the same to me. Or I could switch this red marble with one of those. Or I could switch all 3 of those green ones around. So right now, do you understand what I mean about distinguishable permutations, ones that actually look different? Because I've got some things repeating. So we want to try to figure out how we can calculate how many ways there are of that. Let's begin by saying, let's suppose that they did all look different. And I just got 10 totally different marbles. How would I figure out how many ways I actually can arrange 10 different marbles? Morgan? So 10 factorial. Whether I can tell them apart or not, that's how many ways I could actually line them up. Now, when we had people in a circle and we had 4 of them that we were moving around, we had to divide by 4 on that because we had 4 repeats, right? Okay, now I want to figure out how many ways can the red ones repeat. How many arrangements do I have just for the reds? So I could have this red first, and then this one and this one, or I could put this red first, or I could put this red first. So how many choices for my first red do I really have? 3. Once I fill in the first red spot, how many choices for the next? And then, so altogether, 3 factorial ways of arranging the red ones. So I need to divide by 3 factorial. Blue is going to be the same, right? Because I've got 3 of those. So I also need to divide by the 6 ways that I could arrange the blue ones, 3 factorial. What about green? What do I need to divide by there? I need to divide by 4 factorial because I have 4 times 3 times 2 times 1 ways I could move the green ones around in those 4 spots that would all look the same. So punch this in your calculator because I don't really feel like calculating that mental math. Casey, you have it already? Thumbs up, 4,200. Okay, most thumbs are up, so most of you must have gotten that. And this asks for permutations, so that is how we will label it. Questions on that example? Okay, then let's go back to the formula list so that you can get this one copied down as well. So if we have n things total, it's n factorial in the numerator, and then we look for however many ones repeat. And if we have 5 of one kind, it's a 5 factorial, 6 of another kind, it's a 6 factorial, whatever repeats, however many of those that we have. And then we have one more example that I want to do, and then one of the ones off of the homework set together. So let me just give you guys enough time to finish getting the formula copied down. And it looks like we're just about finished copying that. Okay, let's do one last example with these distinguishable permutations. So you'll have a lot of ones in your homework sets that talk about taking the letters in a word and rearranging them. So we're going to use all of the letters. It's like we're playing Scrabble, and we have the tiles that would spell out nonsense. And what else could we do using all of our tiles, whether they're real words or just nonsense gibberish? How many different ways could we arrange them? So first thing we need to do for the numerator is to count how many total Scrabble tiles we have for this word. So 1, 2, 3, 4, 5, 6, 7, 8. So what do I do with the 8? What does your formula say you do with the 8? Maya, what do you think we do with the 8? Okay, like that. 8 factorial in the numerator. Okay, I want distinguishable. So are there any letters that I can't tell apart? Are there any letters in that that look the same as each other? Chloe? Okay, so there are 3 n's. So what do I do about the 3? I divide by 3 factorial. Is n the only letter that repeats? Jack? Okay, s. How many s's do I have? So what do I do with 2? And yes, I know it's really also 2, but we're going to write it as 2 factorial to help us get the formulas in our heads. So N's and S's. Anything else that repeats? Abby S. Are N's and S's the only letters that repeat? And how many E's do I have? So what do I do with 2? I divide by 2 factorial. Anything else that repeats? So we have them all. So help me out with your calculators here. Have it already? 1,680. How many got 1,680? Gradually seeing some hands going up. Okay, and we need to label that. They asked for permutations, so that's how we'll label it. Is everybody comfortable with that? Okay, let's do number 1 on the homework set together, because it is weird. You think you need this formula that we've just learned because it says distinguishable ways. You need the vocabulary of what we've just learned, but not the formula, because they throw in this other restriction. Ones that are the same color can't be beside each other, and we don't know how to put those 2 kinds of things together in one formula. So I'm kind of stuck. What is a good strategy when you're kind of stuck? And don't say, go ask your friend or go ask your teacher. What do you do when you're stuck? Maybe it's on ACT, so the stakes are high, and you want to see if you can come up with some idea of what you can do with this. What would you try? What would you try? Drawing a picture. Let's see if that gives us any insights. So let's draw a picture, diagram of one way that we might arrange these. So let's see, I've got 6 marbles, right? Okay, so tell me how I could start a picture for one thing that might happen, just to see if I can get a feel for what's going on with this. How might it start out? What might I have in the first place? I've got these red and white marbles. What might I put in the first place? Ayla? I might put a white marble in the first spot. Everybody agree that's something I could do? Okay, now, if I've got a white marble in the first spot, what are my options for the next spot? Oh, I don't have any choice, just red? Okay, so if I've got white, red, what about the next spot? Do I have any choices? And then, so if I chose to start with a white marble, the only thing I can do is going to look like that, right? I could switch these 2 reds, but it's still going to look the same. That's why I mean we need to know the vocabulary of this, but not the formula. So if we start with a white, it must look like that. One possible way. Do I have to start with white? No? Ryan, what else could I do? Oh, so I could start with red, and then everybody, what would the rest of it look like? So if I start with a red, that's the only way it could look. I could switch some marbles, but it would still look the same. So I've got one option if I start with white, one option if I start with red. Anything else I could start with? So how many total possibilities did I have? 2. So answer is 2, and there's your work that you need to show for that. So anybody with questions on that one?